all, I am thankful to the organizers for giving me the opportunities to present my views over here. My title of the presentation is Blockchain-Driven Transparency and Sustainability in Chemical and Process Industry Supply Chains. So this is what the outline of the presentation will go with: the introduction, chemical supply chain challenges, sustainability and transparency in the process industries, blockchain technology fundamentals, what is IoT and smart contract integration, sustainability monitoring and ESG compliance, industry applications and some case studies, benefits and challenges, future research direction, and at last we will have some conclusions with the discussions. So let us start with the introduction. Why we need a transparency in today's date and why we are looking towards the sustainability. Nowadays, a lot of people are talking about the word sustainability, right? So why it is important? Basically, chemical and process industries are fundamental to global economic development and support sectors such as energy, pharmaceuticals, agriculturals, polymers, and specialty chemicals. Modern industries are increasingly expected to balance economic growth, environmental responsibility, and social accountability. So increasing concerns related to carbon emissions, resolution utilization, waste management, regulatory compliance, and supply chain transparency are reshaping the future of chemical process industries. So ensuring the transparency in raw material sourcing, manufacturing processes, product quality, and environmental performance has become essential for building stakeholders' trust in achieving sustainable industry operations. So digital technologies are emerging as key enablers for creating sustainable, transparent, and resilient industrial ecosystems. So basically, when we go towards any part of industry, not restricted to the part of chemical industry, nowadays people are facing so many trouble regarding the maintenance of their environment, their ecosystem, their data set, and their stakeholders. So everything should be on the point. Point means it should be on the hand. Immediately it should be given to the customers. Immediate help should be developed. And everything should be in a very fast and rapid manner. So because time is very important nowadays for each and every individual. So basis on that, the industries are evolving drastically. So evolution of industry system from industry 1.0 to industry 6.0. Say for example, when we have the technologies of steam power and mechanical systems, mechanizations of productions. Then industry 2.0, it came with electricity, assembly lines, and mass production and productivity started. Later on, it came with the industry 3.0, where computers, electronics, and automation came. Process automation and efficiency was the primary focus in that part. Later on, we came with industry 4.0, where IoT, introduction of AI, big data, cloud computing, and blockchain came in that part. Smart and connected manufacturing was the primary focus, because from that part, the smart manufacturing process was started since from industry 4.0. In the era of industry 5.0, human-machine collaboration, sustainable technologies are the key technologies which came with the development or the era of industry 5.0. And human-centric and sustainable production was the primary focus. And now we are running with the era of industry 6.0, where cognitive AI is there, digital twin is there, Web 3.0 is there, and quantum technologies are there with us. So in this, the primary focus is autonomous, intelligent, and sustainable industrial ecosystems. So basically, the evolution of industrial system reflect a shift from mechanized production to intelligent, interconnected, and sustainable ecosystems where data, automation, and trust are critically enablers of industrial transformation. Among the enabling technologies of Industry 4.0, blockchain has emerged as a powerful for establishing trust, transparency, and accountability across modern chemical and process industry supply chains. So, why we are looking towards all these industries? We must have the curiosity in the mind that why we are talking about the backdated industry and why today what it is going on, that how rapidly the transformation came. That is what we need to look towards, right? So, for that, we have also challenges in traditional chemical supply chains. fragmented information system, limited end-to-end traceability, lack of real-time monitoring. This is very, very important when we personally meet the industry people. They do talk about that real-time monitoring is very essential for us. Regulatory and compliance are also the challenges for them. Information asymmetric and trust issue. This is very fundamental thing and which is widely solved with this technology that I'm going to talk about today. And data integrity and security risk. So supply chain, basically, when we start with raw material, chemical processing, manufacturing plant, it goes to storage, logistic, distribution, and finally it goes to the customer. So data, limited visibility, manual verification is not possible, delayed reporting always happens, and then trust is going to vanish with the customers. So traditional chemical supply chains often suffer from fragmented data, limited traceability, and inadequate transparency, making sustainable and compliant operations increasingly difficult. Now, sustainability and transparency in modern process industry. How it is? Modern chemical and process industry must balance economic growth, environmental responsibility, and social accountability while maintaining complete supply chain transparency. Well, we talk about environmental sustainability, social responsibility, and these are the three different things. So there, carbon emission reduction, worker health and safety, cost optimization, energy efficient, ethical sourcing in social responsibility, and operational efficiency with economic sustainability. So these are the three comparisons of ESG, ESE, that is economical sustainability, social responsibility, and economic sustainability. Basically, transparent supply chains depend on end-to-end traceability of raw materials, real-time visibility of production process, continuous quality monitoring, environmental performance assessment, and robust compliance verification mechanism. So this is how the modern industries are maintaining their sustainability and transparency with the different processes. Now I come to the point where I am going to talk about why blockchain. What is the role of the blockchain in this industry and why it is going to be so emerging and so helpful for certain industries. So blockchain technology is basically building a trust in the industrial ecosystem. Now the question arises, madam, what is a blockchain? What you are talking about as in trust and for the industrial ecosystems. Basically, it is nothing but it is a ledger. This technology was evolved by Satoshi Nakamoto in 2013-14 as a first Bitcoin, which is a cryptocurrency, right? This technology was developed for the purpose of finance. It is yet not completely developed for any type of industry, but yes, it is going on under the different process with the different types of industry that different blockchain platforms are now evolving and coming with the help for the industry. So blockchain is nothing but it is a digital ledger where we can open an account without any papers, without any signatures. Yes, but we do have a signature which is supported by cryptography, means it is secured with cryptographic algorithms and the logics. So here, it is a decentralized, immutable digital ledger that enables secure, transparent, and tamper-resistant recording of transactions across a distributed network. So what are the key characteristics of this blockchain technology? Number one, it is immutability, which records cannot be modified once validated and stored. Second is decentralization. Now, when we come to the blockchain, actually, there are many types of blockchain. So it is a public blockchain and it is a private blockchain. Those who are having public blockchain, it is 100% transparent. When we deal with a private blockchain, it is 70% and 30% ratio in the form of transparency. But the people, those who want to deploy everything with the industrial ecosystem, they are working with the part and evolving the part of public blockchain. So, transparency. Authorized stakeholders can access and verify transaction history. Anyone, even if I don't have an account, then also I can verify that which type of transactions are going on without having also an account, right? Security. Cryptographic mechanisms protect data integrity and authenticity. Traceability. Every transaction can be tracked from origin to destination. Smart contracts, automated executions of predefined business rules and agreements. Okay. So how this blockchain is developing the trust? Basically, traditional database and blockchain. So what is having the traditional? All of we are knowing that when we go with the traditional part of the data set, we are storing our data set with cloud platforms, right? Many of the cloud platforms are charging high cost of energy, and they are also many times it is not remaining secure and transparent also. So this is called the centralized control system. And blockchain is having distributed network where the data is stored very securely, transparently, and less efficient energy cost also. Vulnerable to data manipulation, tamper-resistant records in blockchain, limited visibility of the data in traditional database, where here the shared transparency, anyone can see the data if, but the condition is if I do have a password for that particular ledger. Manual verification, automated validation, single point of failure. Here it is a high resilience of failure because it is not dependent on one authority. By providing secure, transparent, immutable records, blockchain enhances traceability, promotes trusted collaboration, supports regulatory compliance, improves sustainability reporting, and strengthens stakeholder confidence throughout the supply chain. So basically, supplier will go with the part of manufacturer, then logistic, then distributor, and then the customer. And this is how the blockchain technology store everything with the part of customer and deal. Now, what are the core components and architecture of this blockchain? Basically, how the blockchain works, that is what from this I want to explain you all. First of all, the transaction is initiated by one party. If suppose I am and want to open an account with the blockchain, any of the blockchain nowadays, there are more than 500 to 700 blockchains, and still this is going to evolve more and more in the coming near future. So transaction get initiated, then it gets verified, then it is going to be stored with the block, and then ultimately this is where the transaction got verified. Hello, am I audible?
Yes, Shukla, you're audible, but the slide is not up yet. Can you show the slide, please?
Oh, just I will share it once. Is it visible?
Yes, Dr. Shukla, you can continue.
Okay. Yes, so I was actually explaining the core components and architecture from this slide for a blockchain that I will repeat once again as my slides were not visible. So transaction get initiated, then it get verified, then it will go to the block. And here the means go to the block means block will be created after the transaction get verification. Then that block will go towards the part of consensus validation. Then consensus validation will be finally, once it is validated, it will be added towards the block, and then entire blockchain will be with the among entire network. So what is this role of entire all these components? Transaction, verification, block created, consensus validation, block added, and finally shared across the network. So stored transaction records, timestamp, and other relevant data. Unique digital fingerprint of each block that ensures data integrity. So say for example, this is one block, two block, three block, and four block. There are many blocks, but how it get? Your data will come, your timestamp will come, then hash will be generated. It is related with the previous hash. So one block is created in this way. After that, all these blocks will relay upon a smart contract. That what are the execution features need to be highlighted. Smart contract is nothing but it is a digital code which provides the security towards our entire ecosystem of the blockchain. So what is consensus mechanism? That validates transaction and ensures agreement among authorized participants. What is a distributed ledger? Share and synchronized ledger maintained by all participants. Smart contract is self-executing digital agreements that automate business rules and ensure their compliance. So this is how the smart contract will provide the security which will protect the data using cryptography and advanced security mechanisms. Traceability. So it enables end-to-end tracking of every transaction, transparency, which provides visibility and access to authorized stakeholders, automation, which reduces manual process through smart contracts, and trust creates a single source of truth for all participants. So basically, blockchain combines distributed ledgers, cryptographic security, consensus mechanisms, and smart contracts to create a trusted and transparent digital ecosystem. So these are the main core components for the blockchain, and it is shown. Now, blockchain enables supply chain management because, as I mentioned in the architecture part, end-to-end traceability is there, tracks raw materials, products, and transaction throughout the supply chain lifecycle. Secure and transparent data sharing provides a shared immutable ledger that enables trusted collaboration among all the stakeholders. What is automation and compliance for this industry? It automates verification process through smart contracts, supports regulatory compliance with tamper-resistant records. Trust, sustainability, and efficiency. Enhances stakeholders' trust, improves the sustainability reporting, and reduces operational risk and inefficiencies. Blockchain transforms fragmented supply chains into connected digital ecosystem by providing a single source of truth for all the stakeholders. Now, what are smart contracts for automated verification and compliance? So, smart contract is basically supplier will verify all the approved suppliers before material procurement, right? Quality compliance automatically validate product specification and quality standard. Environmental compliance monitor emissions and resource consumptions against predefined thresholds. Automated reporting will generate immutable records for audits and regulatory inspections. So smart contract will flow in this way. Raw material will be delivered, quality parameters will be checked, and smart contract finally gets verified. If it is approved, the record will be noted down in the blockchain. If it is rejected, then there will be alert and corrective action will be given to the person who is deploying the smart contract. So what are the industry benefits? Which will reduce the manual intervention for the data, faster compliance and verification, real-time decision making, improved data integrity, lower operational cost, and enhanced stakeholder confidence. So this is how chemical industry, if the recorded emission level exceeds the regularity thresholds, generates an alert, records the event on blockchain, and initiate corrective action procedures immediately. So this is how it is important for the chemical industry. So smart contract transforms compliance from a periodic manual activity into continuous automated and transparent process. So this is how the three things are very important: automation in the industry, transparency in the industry, and compliance in the industry. And that is why the trust will be generated in this form of operations. Okay, I hope my slides are visible, right? Is my slides visible?
Yes, Dr. Shukla, is it visible?
Okay. Sorry to ask you, but as in between it was not set. IoT and blockchain integration. So now I am integrating two technologies. So IoT, we can also integrate IIoT. This is Internet of Things, and IIoT is Industrial Internet of Things. We can have many combinations with this technology though. So IoT sensors continuously collect real-time operational environmental data from industrial process. Blockchain securely records and stores sensor-generated data in an immutable and distributed nature. Smart contracts automatically verify process conditions and trigger predefined actions when compliance thresholds are met. Real-time dashboards provide visibility into production performance, resource utilization, and environmental impact. Critical parameters such as temperature, pressure, humidity, energy, consumption, and emission can be continuously monitored. The integration ensures regulatory compliance and informed decision making across the supply chain. So, how this real time monitoring and traceability will come to this industry? So, basically, continue monitoring data, tracking the process of parameters, equipment performance, and environmental conditions. End to end traceability means tracks the materials, products, transactions from raw materials, sourcing to end customer delivery. So supply chain visibility provides stakeholders with instant access to trusted and verified operational data. Protective risk management, data-driven decision-making, and immutable record keeping. So basically, if I have my IoT sensors with my industry, I can directly connect that sensors to this raw material. So raw material will be connected with this IoT sensors. Then chemical process will be also connected with the IoT sensors. Manufacturing will be also connected with that. So all the 6 parameters will be collected. Now I will connect this IoT sensors through my smart contract to the blockchain technology using the development of different or as per the requirement logic. So basically, it will improve product quality, enhance supply chain transparency, faster issue identification and resolution, better regularity, reduce operational risk, and increase stakeholders' confidence. So this is how real-time monitoring happens in this industry. Sustainability monitoring in environmental social governance compliance. So continuous monitoring of carbon emissions, energy consumption, and water utilization. Real-time assessment of environmental and social governance performance. Blockchain ensures secure, transparent, and tamper-proof records. Smart contract enable automated compliance verification. Enhanced traceability support responsible sourcing and supply chain accountability. Trusted sustainability data improves regulatory compliance, stakeholder confidence, and ESG reporting. So now, carbon footprint, which is now very emerging, tracking and environmental performance assessment. Continuous monitoring of carbon emission across production, transportation, and distributed activities. Real-time tracking of energy consumption, water usage, and resource utilization. Blockchain provides immutable records of environmental performance data. IoT sensors enable accurate measurements of emissions and operational parameters. Smart contracts support automatic verification of environmental compliance standards. And finally, transparent reporting helps organizations achieve these ESG goals and sustainability commitments through this technology by combining two technology. This is what I am telling, IoT and blockchain. So what are industrial applications in this sustainable chemical manufacturing? If your industry is connected with IoT, and then the sensors continuously monitor this process parameter, energy consumption, water usage, and emission in real time. Blockchain securely records operational environmental data and ensuring transparency and data integrity. So real-time tracking of carbon emissions and resource utilization supports sustainable manufacturing practices. Transparent ESG reporting enables reliable sustainability assessment and audit readiness. Enhanced traceability and accountability improve stakeholders' confidence across the supply chain. And this is how the efficiency and reduced environmental impact contribute to the greener and more resilient manufacturing operations. So, how this catalyst lifecycle management is there through this technology. So first of all, we will go with the part of blockchain where we have to end-to-end trace the catalyst lifecycle activities, then need to connect with the IoT sensors, continuously monitoring this catalyst performance and operation conditions. The smart contract automate catalyst regeneration and replacement of the decisions. Catalyst regeneration, reuse, and disposable activities are securely recorded. Immutable lifecycle records support compliance and sustainability reporting, optimize catalyst utilization, reduce waste, cost, and environmental impact. Say, for example, if petrochemical plant tracks the catalyst uses, efficiency, regeneration, and recycling through blockchain and IoT, improving catalyst utilization, reducing waste, and ensuring regulatory compliance. So this is how the cycle it is: deployment, performance monitoring, regeneration, resource recycling, and sustainability. So what are the benefits and challenges and future direction? So the benefits are: enhances end-to-end traceability, real-time visibility, and stakeholder trust across the entire chemical supply chain, enable automated compliance verification, trusted sustainability reporting, and improved resource efficiency for sustainable operations. Challenges are scalability, integration with legacy industrial systems, and high implementation cost can hinder large-scale blockchain adoption. So data privacy concerns, lack of standardized framework, and evolving regulatory requirements remain key barriers to implementation. Future direction: integration of AI, blockchain, and digital twin will enable predictive sustainability analytics, intelligent decision making, and autonomous industrial operation. Industry 6.0, Web 3.0 ecosystem, circular economy practices, and quantum safe blockchain technology will drive the next generation of secure, sustainable, and resilient supply chains. So, key takeaways and conclusions. So, blockchain is transparent, traceable, and trust generated. IoT-driven real-time monitoring improves visibility of operational and environmental sustainability parameters. Smart contracts will verify and make the decision accuracy. Blockchain-based ESG monitoring supports carbon footprint taking and sustainable manufacturing practices. Industrial applications such as sustainable manufacturing, catalyst lifecycle management demonstrate significant and operational environmental benefits. The convergence of blockchain, IoT, AI, digital twin, and Industry 6.0 will drive the next generation of intelligent, resilient industrial ecosystem. So basically, blockchain is an emerging key enabler, transparent, traceable, sustainable chemical supply chains, transforming traditional industry operation into intelligent, data-driven, and environmentally responsible ecosystem. So these are my references that I have used to prepare this presentation. So thank you, one and all. Present over here.